All right, this is our problem involving two strong agents, the base and the acid. So we see magnesium hydroxide, and the magnesium is just a group 2 metal like sodium. It's just going to completely dissociate and give us two hydroxides. So we're not even going to put this into our balanced equation. And we have it reacting with a strong acid. So we know this is a strong acid plus strong base type problem where we just deal with them reacting with each other and not even worry about the water. We're going to find out who's wins in the end, who's still standing, and figure out the pH from there. So let's go ahead and put our balanced equation down. We're going to have just the hydroxide. We're not even going to worry about the magnesium. We're going to add that to HCl. We could write it as H+, but we'll just keep it as HCl. And we're going to have this as chloride. And the reason we did this is because we had two equivalents of OH for every magnesium hydroxide. So I just kind of wanted to deal with the problem right out of the gate and not have it be part of our coefficients. And you can do that. That's fine. You can do it the other way also. You can put magnesium hydroxide down here as is. But it might be something you might want to try just to make things a little bit easier. So we're going to find out how much hydroxide we have. We're going to have to multiply the molarity times the volume and then double it, because we have two hydroxides. So 0.56, we're going to multiply by the 0.0145, I guess, because we have to change it to liters. We have to move the decimal point 3 places. And we're going to times that by 2, and that's going to be our initial amount of hydroxide. It turns out to be 0.01624. And our HCl, we're going to find 0.75 times 0.00575. And we come out to have this as 0.0043125, but I'll just round it to 0.004313. So this reacts, we can see where we have a excess of the OH. So we're going to subtract what we don't have excess of. It's going to be limiting reagent. We're going to subtract that. And we're going to have some amount then left of our base, but not of the acid. And I'm not even going to worry about this stuff over here. We could say, of course, this was water, it's in, and it's a 0, but we're not worried about this. We're worried about who's left standing over here. And it's going to be hydroxide. So let's go ahead and subtract that from our 0.01624, and we get then 0.01192, and we'll leave it as 875 there. But this is our amount of moles, we're working in moles, of hydroxide at the end of this reaction of a strong acid with a strong base. So now we need to move to, how do we get to pH? Well, we're going to go first to molarity of our OH, and how to do that is we have to take the mole amount and divide it by the volume. So we can say, hey, that mole amount, we know it came through this addition of two solutions. We're going to divide it by the total volume here that we have. So I'm just going to take the 14.5 plus the 5.75, and we're going to move the decimal point over 3 places, and we're going to have our molarity. So we have now a molarity of 0.589. I know I should have a leading 0, but that's our molarity of OH. So to get to pH, we need to take and determine the negative log of this, and I'll do that. And then we're going to take that from 14, because we know that 14 is equal to POH plus pH. So as soon as I find the negative log of this, I can plug it in and find pH. So we get, and we take the log of that, we get minus 0.229, but we're going to take the negative of that. So if we take the log of this, it's a negative 0.229, but we're going to take and we're taking and changing the sign. So it's going to be 0.2, we'll say 299 is our pOH, and we're going to subtract that from 14. So we get a pH equal to, if we do this, and we isolate this, I'm just going to move it to the side, we can find that pH to be 13.77. So it's a very basic solution we're left with, because our 14 wasn't changed much. We had this pOH, we had to move to the other side, and I didn't give myself enough room, but all we did is plug the pOH value in, subtract it from 14, and we have 13.77 left. Hope that helps for strong acids reacting with an excess of our base, our strong base. Thanks. Bye-bye.